All right, so these are cyclic compounds, and we call them cyclo to talk about how they go back and grab the end of the tail, so to speak, like a snake biting its tail. Okay? All right. Now, in this class, we haven't done organic or compounds or hydrocarbons with anything other than single bonds. Okay? So all of the organic compounds we've done have been hydrocarbons. Okay? They're hydrocarbons because all they contain are hydrogens and carbons.
So
All we've done are hydrocarbons.
what would the inside would be a cyclodecane?
I don't have a 10 in a circle? Yeah, it'd be a cyclodecane. Yeah. Okay? We've done hydrocarbons, and all of them have nothing but single bonds. And carbon chains with nothing but single bonds are called alkanes. Okay? Carbon chains with nothing but single bonds are called alkanes. Carbon chains with nothing but single bonds are called alkanes. Carbon chains with nothing but single bonds are called alkanes. Okay? So all the hydrocarbons we're doing so far have been alkanes. Okay? All right. We're going to move outside of this category we call alkanes for a minute because it's a really important cyclic or circle structure you need to know about. This structure has alternating double bonds. Okay? Alternating double bonds in a cyclic structure of 6 carbons. Okay? This is called a benzene. Benzene. They're double bonded lines, like we do double bonds. Okay? Alright, in reality though, that second bond, that pi bond, remember it goes above and below the sigma bond to make a pi bond. Okay? Sigma bonds are directly on a line between two nuclei, and a pi bond has two parts that go above and below that. Okay? These pi bonds don't actually sit in these 3 places. They move around. Okay? They're not really centered in one place. They're shared through that whole structure. So chemists, to sort of communicate that sharing of that double bond all the way around that circle.
Do they orbit?
No, not really an orbit, no. They're just shared through the whole thing. Okay? They have a different way of drawing a benzene that looks like this, just to show it's shared all the way through. So this is another way of drawing a benzene.
So it has to have, what, half of the double bond on the whole thing?
You could say that. Yeah, that's another way of thinking about it. Half a double bond all the way around. But it's really more complex than that. Just know the double bond is shared through the whole thing, okay? Don't try to do the math because it really doesn't define what's going on too well. Okay, here. All right. So, now these circle structures with that double bond structure around the top and bottom are really, really important in chemistry. If I take a bunch of these and link them together,
So what are those shapes of the benzene?
these are benzene rings, and I'm linking them together like this. What? I don't know. Maybe you should.
Let it be out.
It does come like a beehive, doesn't it? From the top anyway, a beehive looking down from the top of it.
Wasp nest.
But this is actually flat, okay? So if you get enough of these strung together like this, you have graphite.
Oh shoot.
Graphite is a form of pure carbon. Almost no hydrogens on there at all. And I bet every one of you have some graphite in your possession.
What's that? No, I don't.
The so-called pencil lead. Where you're supposed to, right?
Now you have something in possession right here.
I thought they stopped making like real lead.
They did. We still call it pencil lead, but there's no lead in pencil anymore. Lead is a heavy metal, and students have a tendency to put it in their mouth, and it gets in your bloodstream. It causes liver damage and brain damage and things. You don't want to mess with the stuff. Okay? They used to have lead in paint too. They don't do it anymore. And lead in gasoline. They don't do that anymore.
They got unleaded.
That's right. Unleaded.
So what's in pencils?
What?
So what's in pencils now instead of paper? I use that.
Graphite.
Okay.
All right. So this is flat. All right. Now I want you to use your brain here. Use your imagination a minute. Think about this flat structure. We're going to pick it up and we're going to turn it sort of sideways. Okay?
Oh yeah.
And then you get this thing I have in your text, which shows four of these layers.
That thing.
Okay?
That-
This right here. That's showing how graphite sort of sits on top of each other. But the thing is, they got all those double bonds that sit on top and bottom of the thing, so they push apart. They won't actually stick together. And that's why graphite's so slippery. We use graphite as a dry lubricant. Okay? If you need something you need to lubricate something, but you don't want it with something that's liquid like an oil, you use graphite. Okay? Now carbons, if you take these carbon sheets and roll them up and attach them to themselves, you take these carbon sheets like this graphite sheet, and roll them up into a tube, you get something called a carbon
Whoa.
nanotube.
If you roll.
If you take a sheet of these things and you roll it up so it makes a tube, you get something called a carbon nanotube. Carbon nanotubes are extremely important now.
Is that what lead is?
No. Carbon nanotubes have become very, very important in making very lightweight and very strong structural materials. It also has great promise in creating submicroscopic electronics, because you could make a carbon nanotube, and theoretically electrons have no resistance going down the middle of those tubes. So there's no heat buildup. So if you had a computer where all the transfer of electricity, all those pulses of electricity that make a computer work, were replaced with carbon nanotubes, they wouldn't get hot,
Why don't they do that?
because they don't have the technology to do it yet.
How do you
Okay.
know about it?
Huh?
How'd you know about it? Why don't you tell me?
I'm telling you, theoretically, that's what's supposed to happen.
Oh.
Okay? There was a young man from, I forget, out west somewhere that a few years ago won the International Science and Engineering Fair for providing solid evidence that carbon nanotubes could be dissolved in a solvent. Okay? All right, now there are other forms of pure carbon. And one of them is a diamond. And if we take all carbon atoms and link them together in this sort of arrangement here, okay, that's the way that carbon atoms are put together to make a diamond. And that's, again, pure carbon. So graphite, nanotubes, and this sort of thing are all pure carbon atoms.
I think it stops it every now and then.
Say what?
Like you pour it, it stops it.
So each carbon is bonded to 4 of the carbons. Okay? 1, 2, 3, and one back here behind 4. Okay? I'll pass that around for you to look at if you want to. All right, there's still another somewhat rare, but another form of carbon that's pure carbon. What? Yeah. It's called a buckyball.
Looks like a soccer ball.
It does, doesn't it? Okay. The long name for this is a Buckminster fullerene.
What?
It's 60 carbons bonded together. Okay? Yeah, we call it buckyballs for short. Hmm.
What page is it?
That's on page 188.
Oh my God, we got.
So you need to take a few minutes and look over these 187, 188 pages about carbon, okay? This is Buckminster fullerene, also called a buckyball. All right? 60 carbons put together. And yet has that alternating 5-sided, 6-sided shape like a soccer ball. Y'all need to stop some of that. Huh?
I was talking to man.
Well, let's pay attention to this, okay? A little too much of that, not enough of this. All right. Now, all these different forms of pure carbon, all of these different forms of pure carbon are allotropes of carbon. Allotropes. All these different forms of pure carbon are allotropes of carbon. Allotropes are different forms of the same pure element differing only in the way the atoms are bonded together. And there are lots of different elements that have different allotropes. Well, that's just a small, tiny piece of a diamond, okay?
How many carbons is there?
There, in that structure, I don't know, was it like about 20 something maybe?
20 carbons?
30 maybe, I don't know. The thing is, if a carbon had that few diamonds, you couldn't even see it. It'd be way too small to see.
All those are carbon?
Yeah.
I thought there was some hydrogen.
No, there's all pure carbons. We're talking about pure elements here. Graphite.
Don't count that.
Graphite is pure carbon. Diamonds are pure carbon. Buckyballs, pure carbon. Nanotubes, pure carbon. Okay? All right, might be that. But they're just bonded together. In fact, there are two different structures that make a diamond. Two different ways of putting the carbon together that make a diamond.
I thought you said that they had a little bit of hydrogen. No, not at all.
Now, around the outside edges, maybe. But in the structure itself, no.